In this video, we will create the Nexus Dashboard 4.1 cluster using the nodes we configured in the previous videos. Once we start the physical nodes or the VMs, we must wait for them to complete the boot process until they display the following message: System Interface Online Login at HTTPS, followed by the IP address we configured earlier to continue. Once you receive that message, open your browser and go to that URL. At this point, you must use the password you set in the previous step. Once access is validated, we begin the cluster creation process. And it's right here, from the start, that we begin to see the advantages of this tool. The first thing we'll find is an overview of the menu options and functionalities that will be available in each section once the cluster creation is complete. First, we start with a guide about some of the main functionalities of the platform called Meet Nexus Dashboard, and includes an overview for those who are new to the tool, a description of managed about the configuration of devices, analyze about the anomalies and advisories that the tool provides, admin with basic information on administration of the tool, and finally, you are ready to start creating the cluster. Once this tour is complete, we will enter the journey that will guide us through all the steps for creating the cluster. These are getting started, key features, and features you should try. At this point, just by completing the previous guide, we will have already completed 25% of the first getting started process. Now we will move on to the next step, cluster bring up. And here's something quite interesting. If we are unsure of what we'll need at each step of the process, we can see that each section has a Learn More guide that provides a description of the process we are about to perform and access the documentation needed to go deeper into that topic. And from here, we begin the cluster bring up process, a 5-step process to enable the Nexus Dashboard cluster. Let's begin. First, we'll assign a name to the cluster and then specify the type of network we'll configure with it, LAN or SAN. If we select SAN, we must indicate which manufacturer we're using for the MDSs and the support, either Cisco or IBM, and then move on to the next step. If we select LAN, once we specify this network type, we move on to the next step. In this video, we'll implement a LAN cluster, so let's continue. Second step, configuration. In this step, the first thing to do is specify whether we will use IPv6 or IPv4, which in this case is the default. For the purpose of this video, we will use IPv4. Next, we will add a DNS provider and click the check mark to save the information. In this section, we can add one or more DNS providers, but we must include at least one. Optionally, we could add a DNS search domain, but this information is not mandatory. It is essential to review the deployment guide regarding DNS. The guide indicates that a lack of valid DNS connectivity, for example by using an unreachable or temporary IP address, can prevent the system from deploying or updating correctly and can also affect the normal operation of services. Nexus Dashboard functions as both a DNS client and resolver. It uses an internal primary DNS server that acts as the DNS solver for internal services. It also functions as a DNS client to access external hosts within the Internet or intranet, which requires configuring an external DNS server. Nexus Dashboard does not support DNS servers with wildcard records. We need at least one NTP server in the cluster, while using authentication on it is not a requirement. We can enable its authentication by specifying the key, the ID, and authentication type fields and selecting the trusted option, since Nexus Dashboard does not support untrusted keys. If adding multiple NTP servers, select one as preferred. It is important to review the implementation guide for details on NTP. If the cluster doesn't have direct access to Cisco Cloud, we can add a proxy and its corresponding authentication parameters. But why we need to access Cisco Cloud? There are certain URLs that Nexus Dashboard must reach that are necessary for these connections. Here are some of the URLs that Nexus Dashboard must reach for these connections and why. To configure the proxy, we only need to add a URL and verify its connectivity. If necessary, we can add the login parameters. Here we can also define exceptions, that is, hosts we want to reach without going through the proxy. Under Advanced Settings, you can configure these settings. App Network, the address space used by the application services running in the Nexus Dashboard. Service Network, an internal network used by Nexus Dashboard and its processes. Third step, Node Details. Here, we'll define connectivity parameters between nodes and between clustered nodes and fabrics. Initially, the cluster's connectivity will be either Layer 2 or Layer 3. In case of Layer 3, connectivity must be via BGP. For the purposes of this video, we will use Layer 2 connectivity. We will use BGP when the nodes are located in different locations, and since persistent IP addresses need to be published, you will need to advertise that network from all three locations. BGP simplifies this process by advertising these persistent IP addresses using the router IDs of each node. We will use L2 when all the nodes in the cluster are on the same VLAN, and in this case, we will advertise the persistent IP addresses from a single location. Next, we will detail the information for each node, such as its name, IP address for the management network, IP address for the data network, and node type. At this point, we'll only see some information about the node we are accessing from the URL. This is where we'll add the remaining nodes of the cluster. To create a physical cluster, you only need to connect to one node, and from there, the other nodes in the cluster will be configured using each node's CIMC IP address. Therefore, it is important that each node in the cluster had its CIMC IP address configured, either via DHCP or statically, so that the cluster provisioning can be completed. In this example, we are using virtual nodes, so we are using the IP address of the management network. For this node we are working on, we only need to add a name and the data network information, but let's take a moment to talk about the node types. There are three types of nodes: primary, secondary, and standby. Primary nodes control the cluster and run workloads. A minimum of 3 are required for full redundancy in a cluster. But if a single node cluster is implemented, that node must also be selected as the primary. Secondary nodes add processing power for greater scalability and co-hosting of workloads. And standby nodes are not actively used but serve as failover to replace a failed primary node. Depending on scale requirements, 3-node cluster can be extended with up to 3 additional secondary nodes for a total of 6 nodes to support higher scale. For physical clusters, you can also add up to 2 standby nodes for easy cluster recovery in case of a primary node failure. Exact numbers of additional secondary nodes required for your specified use case is available from the Nexus Dashboard cluster sizing tool that we presented on a previous video. Returning to the cluster creation process, once we have included all the information for the node we are currently connected to, we can add another node. To do this, we need to enter the IP address of the management network and the password we set during provisioning, and then select the Validate option. Once we have received the node information, we can select the type, add a name for the node and the data network information, and that's it. We'll repeat this process for all the nodes we add to this cluster. Once the nodes have been added, we press Validate to proceed to the next step. Fourth step, persistent IPs. What are they used for and how many persistent IP addresses are required? Persistent IPs are the addresses of the services. Remember that the tool runs containers, and the services within the pods must be exposed so that clients, such as Nexus switches, can use them. For example, this includes the IP addresses to which the switches must send their telemetry. If we didn't use a persistent IP address, the pods will restart and acquire a new IP address, forcing us to constantly reconfigure each switch to send its telemetry to that new IP address. By using a persistent IP address, it doesn't matter if the nodes or the cluster restarts. There's no need to reconfigure each switch's telemetry forwarding to the services. You must use persistent data IP addresses to initialize the cluster. So you must allocate a specific number of persistent IP addresses based on your configuration. If your cluster has one node, allocate 3 persistent IP addresses. If your cluster has 3 or more nodes, allocate 5 persistent IP addresses. If you configure dual stack IPv4 and IPv6, double the number of addresses in both cases. You must assign the minimum required persistent IP addresses during the boot process, and you can assign additional persistent IP addresses after deploying the cluster by configuring external services group in the graphical user interface. Once the persistent IP addresses are included, we can move on to the next, or fifth step, which simply involves validating the summary of all the information included in the previous steps. The provisioning process, which is fully automated, will then begin. Now we just have to wait. As you can see, the cluster creation process has begun. We will be able to see the details of each step in the Bootstrap cluster enabling process. Once completed, we will follow the steps of the main node's Bootstrap process. Finally, the cluster installation. Once completed, the login screen will reappear, but this time you must enter both the admin username and the password you defined during the provisioning process. Once inside, mission accomplished. It's time to start registering the fabrics and viewing the telemetry, but we will have new videos for that soon. See you in the next video.